Hello everyone, good to see you again. This video is a lecture about logistic regression, which is a statistical method to relate the probability of an outcome to various predictors. Okay, are you guys ready? Then let's get started. We've learned two important concepts of CLM, lifetime value, and LFM, recency, frequency, and monetary value. An important managerial message from the lifetime value concept is that managers need to take an action to address who are continually profitable customers. Customer-centric firms are firms that focus on profitable customers in a long run and develop and execute marketing strategies to improve the long-run profitability by enhancing profit contributions from customers, improving customers' retention rate, and reducing costs incurred for customer acquisition. RFM provides a simple method to separate out profitable customers from the customer base. Recency, frequency, and monetary value are metrics that can be simply computed from transaction history data, but they are very powerful devices to find who will purchase more and spend more. Then, move our focus on marketing actions. Suppose that you are a marketing manager and designing a new promotion campaign. These are lots of options for promotion. You may offer extra membership points. A cash credit is a good alternative. A price discount offer is a very traditional but still effective method of promotion. Those promotional efforts may change customers' responses. With a promotional offer, customers may purchase more and spend more. However, lifetime value and RFM do not directly address the effects of the promotions on future sales. In addition, what about customer characteristics? In various markets, it has long been proven that demographics and psychographics are good predictors of demand. Think about gender. My son always picks racing movies, but my daughter has no interest in racing. And how about income? High-income family may be more interested in premium offers than low-income family. Family size is another important demographic. If you have younger brothers, you may know that how much they eat and drink and eat and drink. A larger family may be more sensitive to deals on grocery shopping. Recency, frequency, and monetary value do not directly account for the difference driven by the characteristics. They just summarize the past transactions, and we can't know whether the characteristic difference changes RFM or not, and how much it changes RFM. So, in general, this question more directly tackles what CLM managers face in practice. What and to whom should we offer? For example, when you have two different options, offer A and offer B for promotional campaign, which one should you choose? And once you picked one, then to whom should you offer the promotion you picked? Logistic regression enables us to answer this question. Let me start with a conceptual example. Okay, suppose that you can see the future. What would you do? You may buy a lottery. You know the correct number to win Powerball. You know the correct timing to purchase and sell Bitcoins. You know which stocks you must buy for high return correctly. In consequence, you will get a jackpot. Now, imagine that there is a firm which can see what will happen. The firm knows likelihood that customers take each offer, and the firm also knows the amount of profit coming from the customers accurately. Then, the firm must pick the best customers and offer the best offer to them to maximize profits. A logistic regression model is a tool for this prediction. Precisely, it is a model that relates probability of an outcome to predictors. In this example, the outcome is that the customers take the offer. Using various predictors, including the customer's characteristics and the features of the offer, the logistic regression computes the possibility that the outcome happens. Please note that it is not perfect, but given enough data of offers and customers, it can provide much better prediction than at least a random choice. Then, how a logistic regression model provides prediction? It first analyzes past data to get some clues. For instance, let's say customer 1 had earned $120K and bought the firm's product 5 times last year, and she used a 10% discount coupon when it was offered. Customer 2 had earned $500K and bought the firm's product 3 times last year, and he didn't take any promotional offer. Customer 3 had earned only $80K and bought the firm's product 20 times last year. She took a 20% discount coupon when it was offered. These are past data. From this, a logistic regression extracts clues about the relationship between purchase frequency and coupon usage, and the relationship between the coupon's discount rate and coupon usage, and the relationship between the income level and coupon usage as follows. The more purchases the customer had made last year, the more likely the customer used the coupon. The higher the discount coupon's rate was, the more likely the coupon was used. The lower the customer's income had been last year, the more likely the customer used the coupon. Then, the model makes predictions based on the clues. It's easy. Just change the tense of the clues. Then, the clues become predictions as follows. The more purchases the customer makes this year, the more likely the customers will use a coupon. The higher the discount coupon's rate is, the more likely the coupon is used. The lower the customer's income is this year, the more likely the customer will use a coupon. The prediction directly indicates who to target for marketing activities. Let's look at the predictions. They describe the profits of customers with high predicted probabilities. They describe who are the customers have 80% chance of taking an offer. Then, when we focus on those customers who match with those profiles, we expect better response rate and lower marketing costs to achieve marketing goals. All right, now let me explain what is a logistic regression model. This is a basic grammar of a logistic regression model. It consists of 2 parts. One is a set of conditions, which are called predictors, independent variables, or explanatory variable. The other is a binary outcome, or dependent variable. Here, the term binary means there are only 2 possibilities, like both sides of the coin. An example is that if a 10% discount coupon is offered to a high income customer, she will take it. Another example is that if an extra a 100K membership point is offered to a heavy user, then she will sign up the membership. A logistic regression model provides the probability that the binary outcome happens. This is called predicted probability. So the logistic regression predicts the probability. So for example, a logistic regression says there is a 70% chance that the customer will take it, or there is a 30% chance that the customer won't take it. But a logistic regression model is actually a mathematical model like this. It looks so complicated, but I'm going to explain each component, relating it to the verbal description. First, there are some axes in the right-hand side. They are predictors. Second, the left-hand side stands for the binary outcome. Here, this PR means predicted probability that the outcome inside the bracket happens. And this probability is related to the predictors with coefficients or parameters. They capture how the probability is sensitive to the predictors. And this relationship is mathematically described by a complicated function, which is called a logit model or logit function. For your better understanding, I'm going to explain the details of this mathematical expression with an example. Suppose that there is a company running an annual subscription-based business. This company recently introduced the premium service that provides premium benefits for the service. And during the last year, existing customers who were using the basic service were asked to upgrade. There were promotional flyers which were sent out to the customers several times. Marketing question is that this company wants to know who will sign up the premium service next year. To address the question, marketing managers of this company scraped the data. For each customer, they gathered outcome denoted Y, and that indicates whether the customer finally signed up the premium service or not last year. And annual income of the customer, denoted INC, based on the customer's report. And usage history of the customer, denoted FREQ, which is the number of purchases made. And promotional effort, denoted NMAIL, which is the number of flyers sent out to the customer. Please note that the types of the variables are different from each other. The income variable is a demographic variable like gender, age, family size, income, and education level, and the indicator of the place where the customers live, like zip code. The usage history, more precisely, frequency variable, is a past observation variable like RFM metrics, purchase amount, and the brand the customer chose last time, and the store the customer visited the last time, and so forth. The promotional effort variable and mail is a decision variable like product or service features, price of the product or service, promotions, and sales or distribution channel types. The first two classes of the variables, the demographic variables and the past observations, they are mainly used for targeting. That is, we can profile customers who are highly likely to respond to our offer through those variables. So they are used to identify all to whom we should offer. The other class of the variables is used for, that is the decision variables, and they are used for optimal design of product or service. This is related to how to figure out what to offer. With these predictors, let's complete the verbal descriptions. The focal product is the new premium service. So the description should start with if the premium service is offered and to whom. Think about it by variable. First, income variable. So if the service is offered to a high income customer, then what happened? The outcome. In this example, customers choose one of these, sign up or not. So the description with respect to the income variable is if the service is offered to a high income customer, she is highly likely to sign up. In the same manner, we can complete the description for frequency variable and promotion variable. Now, translate the verbal descriptions to the mathematical formula. Here, the income, frequency, and promotion variables are predictors. So they take axis places. And sign up is the outcome variable. Let's use 1 to indicate sign up for simplicity. And here are parameters. Each variable has its own parameter, which captures the sensitivity of the sign-up probability to the variable. And please note that there is another parameter, beta 0, which is called the baseline. This is not connected to any variables. It just stands alone. And this controls for how the service basically is attractive. If the baseline parameter is high, the service is attractive, and the sign-up probability is high in general, regardless of the customer characteristics and the service and promotion features. That is, even low-income customers, light users, and customers with little exposure to promotions are likely to sign up. But if the baseline is low, the interpretation is reversed. The service is not that attractive. In general, customers are unlikely to sign up. That is, only high-income customers, heavy users, and customers with much exposure to promotions may sign up. And how to interpret the other parameters values? Again, these parameters imply sensitivity. The higher the coefficient value, the more sensitive the probability. Here, I plotted the predicted probability over the size of income. All the other thing is equal. There is only one variation in the model, the income variable's coefficient value. Case 1, that coefficient value is 0. Case 2, it is 1. Case 3, it is 5. If the coefficient is 0, then as in this first figure, the probability doesn't change like this, doesn't change as the income changes. That is, the probability is not sensitive to the income level at all. But if the coefficient is 1, the case 2, then the income variable now affects the probability. So the higher the income and the higher the probability. If the coefficient value is 5, case 3, then sensitivity becomes high. That is, the probability increment. So this increment due to more income is much bigger than case 2, where the coefficient value is 1, which is smaller than the 5. Okay. Now, let's dive into the details of analysis with the logistic regression model. This is a basic procedure. First, we get the data and calibrate or estimate the logistic regression model. Second, interpretation. We interpret the result of the calibration. Third, we make our predictions based on the estimated model. Fourth, we do validation check. If necessary, holdout validation is used. And last, we make our decision based on the result. Suppose that we successfully gathered the data. Then, how to calibrate the model? That is, how can we know the values of the coefficient parameters? The coefficient parameters are the only thing we don't know. They are determined by these steps. First, we need to classify customers by predictor value like high versus low income, high versus low frequency, and high versus low number of flyers sent out. And then we can find the best coefficient values that generate the profile most accurately. This sounds like very complicated, but don't worry, we have software. SPSS or other statistical software will do this calibration for you and for me and for us. And okay, this is a summary table of what would happen with various values of the parameters. Okay, and first let's look at the baseline. Okay, so if the coefficient of the baseline, which is just beta 0, that is equal to 0, in that case, the sign up probability is 50-50. Okay, so the probability of sign up and the probability of not sign up, this is 50-50. But the baseline parameter, is low, more precisely, which is smaller than 0. And that means, in general, customers were unlikely to sign up. But if the baseline parameter is high, more precisely, the beta 0 is higher, greater than 0, and it means, in general, customers were likely to sign up. Then let's look at the income. Okay, so the beta INC, that is the coefficient corresponding to income variable, and that coefficient is equal to 0, then it means that sign up was irrelevant to the income variable. So income variable does not make any change of the probability. But if the income variable's coefficient, beta INC, is greater than 0, but not that high, just low, then it means that higher income customers were more likely to sign up. And if that coefficient is high, then the increment becomes high. So higher income customers were much more likely to sign up. Okay, and then in the same manner, we can interpret the values of the coefficient corresponding to the other variable. Then suppose that we observed the following patterns in data. So from the data, we observed that the sign up probability is 50-50 in general. Okay, and we found the pattern that higher income customers were more likely to sign up, and sign up probability was irrelevant to the past usage history, and more exposed customers were much more likely to sign up. Then in that case, the coefficient values should be beta 0 should become 0, and beta INC should become low, and beta frequency should be 0, and beta and male should be high. So this is a calibration example. We, if we observe different patterns like this, then the calibration changes like this. So when we observe, in general, customers will, very highly likely to sign up, but the income does not make any change, of the probability, and the promotion also does not make any change in the probability, but the usage, the frequency variable, is very effective. So heavier users were much more likely to sign up. So just as that we found these patterns, and then the coefficient values should be estimated like this. The beta 0 should be high, and beta INC should be 0, and beta ML should be 0, but beta frequency should be high. Statistical software conducts the steps that I conceptually introduced and returns an estimation table. Here are lots of information. So this is the estimation table. And here are lots of information, but we need to focus only on the B column and the C column. B column gives estimated values of the parameters, and C column gives corresponding p-values. The p-value measures whether the estimate is statistically different from 0. This is smaller than 0.05. We can conclude that the corresponding variable is significantly different from 0. And this constant rho indicates the baseline parameter, beta 0. And you may have one question at this point. Can a parameter be negative? In the estimation table, we have a negative baseline. What does the negative value mean? For the baseline, if the parameter is positive, the sign-up probability is greater than 50%. In general, that is, basically, customers are likely to sign up. But if the parameter is negative, the sign-up probability is less than 50% in general. That is, basically, customers are unlikely to sign up. And how about the coefficient of a variable? For example, what if beta INC is negative? If it is positive, high-income customers are more likely to sign up than low-income customers. But if it is negative, the relationship is reversed. Low-income customers are more likely to sign up than high-income customers. So, going back to the table, we conclude that, in general, customers are unlikely to sign up because the beta 0 is negative, and high-income customers are more likely to sign up because beta INC is positive. And customers who have more frequently purchased are more likely to sign up because the beta frequency is positive, and customers who received more flyers are more likely to sign up because the coefficient for the N male is positive. The next step is prediction. Suppose that we found the beta 0 is equal to -2, and beta INC is equal to 0.01, and beta frequency is 0.15, and beta M male is 0.21 in estimation. Then the logistic regression becomes this equation. Okay? Given predicted values, we can compute the predicted probability and draw prediction if the customer signs up or not. For example, if a customer's income is 300K and the frequency is 1 and MA is 0, then her predicted probability is 76%, which is very high, right? And that is, this customer is highly likely to sign up and predicted to sign up. But if a customer's income is only 35K and frequency is 6 and MA is 1, then her predicted probability is only 37%. That is, this customer is unlikely to sign up and predicted to not sign up. Then, how to compute the predicted probability? This is the logic function formula. It looks so complicated, but it is not that difficult to understand. Please look at the numerator, okay? And there is exp, which is a function widely used in math, physics, science, engineering, and economics. You don't need to know what it is exactly. Excel and SPSS have a function to compute this, and the function name is totally the same as exp. Instead, focus on what is in the denominator. The exp function appears here again. That is, we need to first evaluate this exp function part, which is sometimes called odds or odd ratio. With the computed odd value, then we can compute the probability via this equation. Then we can make a prediction. If the computed probability is greater than 50%, the customer is predicted to sign up. An example. If there is a customer whose income is 300K, frequency is 1, and ML is 0. The odds is given by exp O minus 2 plus 0.01 times 300 plus 0.15 times 1 plus 0.21 times 0, which equals 3.16. And with these odd values, so we can just plug this number into this equation, and then we can get the probability, which is equal to about 76%. That is, this customer is highly likely to sign up, and because it is greater than 50%, and predicted to sign up. Next, validation. Validation is a process to check whether a model or method works enough to actual use. Again, a logistic regression returns a probability and a binary outcome is predicted. Then the validation condition is that the predicted outcome is the same as the actual outcome, that is, accurate predictions. So there are so many measures, but these two measures, the misclassification rate and lift measure, they have been widely used in practice. So before explaining each measure in the next slides, and please note that hold-up validation technique can be used for logistic regression as well. All right. Then, first, misclassification rate. Because the outcome is binary, only 4 cases are possible. First, the prediction is to sign up, and the actual is the same, sign up. This is correct prediction. Second, the prediction is to sign up, but the actual is not. This means the prediction is different from the actual, so this is the incorrect prediction. Third, the same thing. The prediction is to not sign up, but actual is sign up. So this is another case of the incorrect prediction. Last, both prediction and the actual are the same as each other, and the not sign up and not sign up. And it is also a correct prediction. So high accuracy means more correct predictions and less incorrect predictions. Misclassification rate is based on counting those 4 cases in prediction results. It is given by the number of incorrectly predicted case, divided by the number of the total cases. For example, let's look at this table. The first row here displays the number of cases where the actual is signed up. Whereas the second row shows the number of cases where the actual is not signed up. Then the first column is the number of cases where the predicted value is signed up. Whereas the second column displays the number of cases where the predicted is not signed up. Then these 2 diagonal cells show the number of correct prediction cases, and these off diagonal cells have the number of incorrect predictions. In total, there are 1,459 cases. Out of them, 56 plus 173, which is equal to 229 cases, are incorrect predictions. Divide that number by the total number of cases, we can get the misclassification rate 15.7%. Another validation measure is lift measure. Like RFM analysis, we can classify customers by the predicted probability. And look at this table. The customers are sorted by the predicted probability in descending order. Then they are classified into 3 different groups. In the first group, group 1, there are the top 33% customers in terms of the predicted probability. In the second group, group 2, there are the next 33% customers. And in the third group, group 3, there are the last 33% customers. If the predicted probability is correct, more customers who actually sign up are classified into this high group, and less customers who actually not sign up are classified into low group. Then, counting customers who actually sign up in each group, we have this table. In each group, there are 100 individuals. That is, those groups are equally sized. In the first group, 92 out of 100 customers actually signed up. In the second group, only 63. And in the third group, only 25 customers actually signed up. Then, just accumulate this count from group 1 to group 3. Then, the cumulative sum up to the last group, so this number, indicates the total number of customers who actually sign up. Here, we have 180. Now, suppose that there is another classification, but all customers are classified randomly. That is, this cumulative sum must be proportional because this is just random, right? And this figure plotted the cumulative sums for both cases. So the case, yeah, from our predicted values from the logistic regression and just random, just random allocation. Here in the figure, x-axis stands for the groups and y-axis is the cumulated count. The blue curve is based on the logistic regression and orange curve is based on the random classification. The orange curve shows linear as we expected, right? And note that the blue curve is concave down. So this shape is concave down. Okay? And this is the sign that the logistic regression-based classification works very well. If classification works perfect, all customers who signed up must be in group 1 or sometimes group 2. So in that case, the lift curve looks like this. So it means that the prediction is good and better. It means that the curve should be more concave down like this. The last step is decision making. Please recall what's the general CRM question. What and to whom should we offer? Now we can answer this question. First, to whom? This is related to targeting. The first two variables are customer characteristics, income and frequency. Their coefficients are positive here, okay? So our predictions are higher income customers are more likely to sign up, and customers who have more frequently purchased are more likely to sign up. Then obviously we need to target high income customers and heavy users. Second, what? This is related to product, service, offer, or marketing activity design. For example, let's think about this specific question. How many times should the promotion flyer be sent out? This is also a question for design of marketing activity. For simplicity, suppose that the flyer will be sent out to all customers. That is, all customers received the flyer same times. And then, how to determine the optimal number of flyers to each customer? Then let's do what if analysis. We can do simulation or prediction what would happen if the flyer is not sent out at all, just once, just twice, and just 3 times, 4 times. And based on this simulation, we can calculate the expected profit and pick the best number of flyers which maximizes the profit. Okay, so that is just simple rule and simple procedure. In sum, logistic regression model is a model used to relate the probability of an outcome to various predictors. A CRM application of logistic regression is to address what and to whom a firm should offer. Using customer characteristics and past observations as predictors enables us to profile customers who are highly likely to take the firm's offer. Using decision variables as predictors allows for an effective design of marketing action. Misclassification rate and lift measure are used to validate logistic regression analysis. All right, that's all I have in this video. And then, have a wonderful day and see you soon. Bye-bye.